All right, in this problem, we're asked to watch this video of a ball being thrown straight up in the air and coming back down. And then based on that, here's the information that's given. It says a student estimated, based on the video, that the ball left my hand 1.57 meters off the ground, and after 0.58 seconds, the ball reached the maximum height of 3.28 meters. Use this information to find an equation for the height h of the ball in meters after t seconds. H equals, and then you fill in the rest of the equation. So a couple things to note here. When they talk about the maximum height, that immediately made me start thinking about a quadratic function because quadratic functions are either uh, they either look like a happy smiley face or a sad smiley face, depending on the lead coefficient's sign. So positive lead coefficient would be a happy parabola, and a negative lead coefficient on the x squared term would be a sad parabola. So right when I read maximum height, I started thinking about a sad parabola, the vertex, what we call the vertex. On a sad parabola, the vertex would be the maximum height or maximum of whatever uh, that parabola represents, right? So made me start thinking about a parabola. Now, also, I could think about what would happen if we're tracking the height of an object based on time passing, the passing of time. So when we saw this man throwing the ball up straight in the air, it just went up and straight back down, right? So why aren't we making a straight line as a graph of the ball's trajectory? Well, because the what we're doing is we're tracking it as time passes. So if you're considering your time to be your input variable or your independent variable on the horizontal axis, you start at 0 seconds, and then as time passes, the height of the ball is increasing, but as time is passing, that makes it look like an arc or a parabola, right? So it makes sense to use a quadratic equation to model this. All right, so now that we've figured out that we want to do something with a quadratic equation or a parabola, we start thinking about the formulas or the things that we know regarding quadratic functions or quadratic equations, right? So I started thinking about y equals ax squared plus bx plus c. That's usually referred to as general or standard form, but there's also another form that's called vertex form. So we'll see, this one's general or standard, depending on the text. Now the vertex form is y equals a times x minus h quantity squared plus k. So this one is called vertex form because the vertex point is shown by this form where the h is the x coordinate of your vertex and the k represents the y coordinate of your vertex. All right, so these are two different forms that I'm familiar with regarding quadratic functions and quadratic equations. Now, which one should I use? Well, again, because we're talking about or because we've been given a maximum height, it would make sense to use the vertex form since that would those would be the coordinates of the vertex, the maximum, right? So we can start by taking that ordered pair and plugging it in for the h and k. And just keeping in mind that the h in this formula is not the same h that's used in this the presentation of this problem. And for that reason, we'll put h and t back into the equation when we go to enter the final answer. But in the meantime, I'm just going to use, instead of using h for y, for the height, I'm just going to use y. Since this function is estimating the height of the ball, then we will say the height equals what based on a number of seconds passed, right? So this would be your height of the ball in meters. and it's going to be based on the time in seconds. Okay, so our ordered pairs here, I could just write on the side here. Our ordered pairs are going to be x, which is your seconds, right? And y will be the height or the meters. Height in meters. Okay, so the h and the k that are in this formula, though, the vertex form, these just represent the actual x and y of the vertex point. The x value of the vertex point is h, and the k is the y. So I'll put a note about that also over here. So that vertex is at h comma k, and they've just given it to us in the problem. So we're going to replace those in this vertex form. So we have y equals a times open parentheses, then x minus, and now we will substitute the h given in the problem, right? So the h, the height, or no, I'm sorry, the seconds. Remember, because we're going seconds as the input, the first coordinate is going to be seconds, so the h here will be seconds. It's not the same thing as the height that we were looking at before with the h here, right? So we're going to look at the seconds as the h of our vertex, so that's 0.58 seconds, replacing the h in the vertex formula. And then the k, which is the y coordinate of the vertex, would be the maximum height, 3.28 meters. All right, now we're almost done with this. So what do we need to do to finish this off? Well, let's think about what our final answer is going to look like. Just kind of have it in mind over here. Our final answer should be y equals a times x minus a number, quantity squared, plus a number, right? And we already have a lot of that down. It's just we don't know what this is yet. That should just be a regular number. So we still need to figure that out. So we have the 0.58 and we have the 3.28, but we still need to know what is this. So that's going to be the next thing we're going to figure out. Also, before we put in our final answer, we will then convert it back to using h to talk about the height instead of y, and then whatever a is times x minus 0.58, quantity squared plus 3.28, except for instead of saying x, we will say t for time, just so that it's in line with the setup of the problem, and then we'll get graded correctly for it. Right? So this is really our final answer, what it's going to look like, but we just need to find out what A is. So we're trying to get to that eventually. I'm going to use a different color for that. We need this next. Okay, so how do we do that? Well, you can only solve an equation if there's only one variable unknown. So we need to be able to find A, that's what we're after, in this step. So that means that we have to find a value for x and a value for y to plug in so that we just have the A to solve for. So that's where we look to our second given point. The second given point in the problem was that the ball left the hand at 1.57 meters. So we know the 1.57 meters would be a y coordinate of an ordered pair. And then we just have to figure out what the x value would have to be to go along with that. And since we're talking about the ball leaving the hand when it's first being thrown, that would be when there was no time passed yet. So we call that initial height, where time is 0. Right? So that's an ordered pair we can use. So we have the initial height. I'm going to write that down. Initial height was given. At 0 seconds, we had a height of 1.57 meters. Okay, so we can use that as x and y into this formula, and then we'll be able to solve for a. So now y equals a times quantity 0 minus 0.58, quantity squared plus 3.28, and I want to also replace my y with 1.57 from the initial height ordered pair. Then we have 1.57 on the left, and we're going to simplify on the right side. Let's simplify this right here. So that'll be negative 0.58. Since it's 0 minus 0.58, that'll simplify to negative 0.58. And then when that quantity, that negative number is squared, it'll become positive. So let's go ahead and calculate that on the side here. Negative 0.58 quantity squared is 0.3364. So now I can write on the right side of my equation 0.3364 times A, get the right color back, A plus 3.28. Okay, next let's solve for A, okay, because we're still trying to get this isolated. So we'll start doing inverse operations on each side, equally on both sides of the equation. So first we'll invert the addition of 3.28 by subtracting 3.28 from both sides. I'll zero it out on the right, and then our equation will be simplified to, on the left-hand side, we need to figure out what that value is when we, why does this thing look so weird? Why won't it let me use a normal cursor here? Interesting. All right, so now I finally got that to work for me. Now I'm going to do 1.57. You can just do this in a regular calculator, minus 3.28. So I got negative 1.71. That's going to be on the left-hand side of my equation. Negative 1.71 equals 0.3364 times A. And then to continue to solve for A, I'm going to divide both sides of the equation by 0.3364. So that will become 1A on the right. And when I divide the left sides by 0.3364, what do we get from that? Negative 1.71 divided by 0.3364, negative 5.08323. I'm going to round that to negative 5.08 because all of the values in the given problem were no more than 2 decimal places. So I'm going to write on the left-hand side, negative 5.08 equals A. And then I'm going to take that negative 5.0A and replace it in the final answer. Right, so here's my final answer. H equals A times quantity, T minus 0.58 quantity squared plus 3.28. So all I'm doing is instead of writing the A, I'm going to change that to negative 5.08308. It's fine. Okay, so that's what we're going to enter as our answer here. Where's my final answer? I'm going to get it back on screen there. There we go. Okay, so now we have negative. Don't forget the negative. I kind of wrote it weird, but it's right here. Okay, negative 5.08 start with. So notice that the h equals is already there, so I don't need that part of it. I'm just in my answer box writing the right-hand side of the equation. Negative 5.08 times quantity, open parentheses, t minus point or 0.58 quantity raised to the power of 2, then plus 3.28. Oh, yep, there we go.